Finding probabilities often involves organizing and arranging the information that we're given, as well as some additional information that we can find ourselves. Here's an example. At a local health clinic, doctors ask all patients to eat an apple every day and eat breakfast every morning. Last year, 1,000 patients received their regular exams. During the exam, each patient was asked if they are making these healthy choices. 350 patients said they ate an apple that day, but 50 of those same patients said that they did not eat breakfast. Also, 540 of the patients who did not eat an apple that day did eat breakfast. What's the probability that a randomly selected patient has not eaten an apple and has not eaten breakfast? What's the probability that a randomly selected patient has eaten an apple or has not eaten breakfast? One way to organize the information is called a tree diagram. It looks like this. The first part of this diagram is the black part at the left. We're told that there are 1,000 patients, so let's write that here. The black part splits into two branches, a red branch above and a blue branch below. Let's use the red branch to represent the patients who ate an apple, and let's use the blue branch to represent the patients who did not eat an apple. We're told that there are 350 patients who ate an apple that day, so let's write that on the red branch. Of course, if there are 1,000 patients and 350 ate an apple, then we can find how many did not eat an apple by subtracting. 1,000 minus 350 equals 650. So let's write that on the blue branch. Notice that the red branch splits into two smaller branches, a green branch and an orange branch. Let's use the green branch to represent the patients who ate breakfast, and let's use the orange branch to represent the patients who did not eat breakfast. We're told that of the 350 who ate an apple, 50 did not eat breakfast. We can write that on the orange branch. Because there were 350 patients who ate apples, the orange branch and the green branch have to add up to 350. In other words, we can find how many patients ate breakfast for the green branch by subtracting again. 350 minus 50 is equal to 300. So we can represent this on the green branch. Notice that the blue branch also splits into two smaller branches, a pink branch and a brown branch. Let's use the pink branch to represent the patients who ate breakfast. And let's use the brown branch to represent the patients who did not eat breakfast. We're told that 540 of the patients who did not eat an apple did eat breakfast. We can write that on the pink branch. Because there were 650 patients who did not eat an apple, the pink branch and the brown branch have to add up to 650. In other words, we can find how many patients did not eat breakfast for the brown branch by subtracting again. 650 minus 540 is equal to 110. So we can represent this on the brown branch. When we use a diagram like this, we can write the expressions that are on each branch and use them to find answers. But usually, in order to save time, we'll use a much simpler symbolic notation. On the red branch, we have the expression, ate an apple. but it will usually be easier to express this with a symbol. In this case, we'll use a capital A. On the blue branch, we have the expression, did not eat an apple. Of course, this is the opposite of what's represented on the red branch, so we'll use another symbol to represent the opposite of A. The symbol that represents the opposite is called the complement. It's written as a bar above the expression. We'll add that to the blue branch. On the green branch and on the orange branch, we find the following expressions: ate breakfast and did not eat breakfast. We'll represent these with B and complement of B. We'll represent the pink branch and the brown branch in the same way. Now that we've organized the information we were given, as well as some additional information that we were able to find with simple arithmetic, we'll be able to use this diagram to answer a wide variety of probability questions.